Hey everyone, welcome to video 2 of this week. We started off this week talking about inverses and identities, and we defined them, and we looked at how to find inverses, specifically additive and multiplicative ones. And now we're going to look at how we can use our knowledge of inverses to do some of the math we want to do. Okay, now another quick refresher. Way back at the start of this semester, right? We started by saying, hey, there's this thing called PEMDAS, and we do not like PEMDAS. And we kind of threw PEMDAS away. We said it was this trick, and we don't like tricks in math because they don't get us very far. Well, there's another trick that Caitlin and I really, 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 really dislike. You've probably heard it before. It's called keep, change, flip. Really just hate me some keep, change, flip because it's hardly ever used correctly. Students don't really understand what they're doing and they get things wrong. And we really believe that to do math well, you need to kind of understand what's going on when you do it. Okay? So we're going to throw away keep, change, flip also. Let's get that out of here. Boom. Oh, not like that. Don't throw it like that. Throw it like this. And we're going to look at a single mathematical concept that we're going to be able to use over and over again. Okay? So let's say we have an expression like this, 6 minus negative 2, and we want to simplify that. And like maybe you're feeling a little bit like this doesn't, how do I subtract it? Negative, what does that even mean? And maybe you're like, oh, I'll just keep, change, flip it, right? Look, I'll keep the 6 and I'll change multiplication or subtraction to be multiplication. That's changing. And then I'll take this 2 and I'll flip it over. Yeah, it doesn't do anything. That's why we hate keep, change, flip, right? So rather than thinking about this from keep, change, flip, let's introduce a single idea. This is actually true for real life too, right? And here it is. Inversing something twice keeps it the same as how it started. Now, what does this mean? Well, let's say I have this pen that I'm using and I'm holding it vertically and I want to inverse the orientation of the pen. So I take the pen and I flip it to be inverted. Well, now if I invert it again, just like this, I get back to where I started. Or let's say that I have my computer screen loaded right now and I want to inverse the colors. So I inverse the colors. Ooh, how does that look? And I don't love this. This is kind of weird. So I'm not gonna undo what I did. I'm just gonna inverse the colors again, and we get back to where we started, right? And this is true even just from straightforward mathematical operations. If I have the operation addition and I inverse that operation, right? So I inverse it, I get subtraction. And if I inverse the operation again, I get back to addition. True for multiplication, division, true for all these different things. Even true for inverse numbers. If I have the number 4 and I find the additive inverse of that number, right? Well, that's negative 4. And then if I find the additive inverse of that number, I get back to 4. So 2 inverses keep something the same. I'm going to quit this magnifier because it's real weird. It's annoying. There we go. So now let's look at a very, very specific case of this idea of 2 inverses. Caitlin and I refer to this as double inverses. Double inverses means something very, very specific to us, right? It means the idea of using both an operation inverse and a numerical inverse. That's where the double comes from. So it's not just doing it twice, but it's doing 2 different inverses. But they really have to be paired off, right? So we're going to use the inverse operation of the operation. We're going to use the numerical inverse of the number, and we're going to see how this creates, well, like we said, something that's the same as how it started, or in this case, the same value, okay? So double inverses means operation inverse, numerical inverse. Let's see what we mean. So here is 6 minus negative 2. Okay, so I'm not going to touch this value of 6, right? But I am going to find the inverse of subtraction. Well, the inverse of subtraction, the inverse operation of subtraction, right, is addition. Okay, so I've inverted once, but I can't do 6 plus negative 2. That won't be the same thing. So now I'm going to find the inverse, the numerical inverse of negative 2, and specifically I'm going to find the additive inverse. The additive inverse of negative 2 is 2. So here's my claim. 6 minus negative 2 is the same thing as 6 plus 2. And how do I know that? Well, because I did two different inverses, right? Or two inverses, one operation and one numerical, but specifically kind of paired together. And 6 plus 2 is pretty easy to know. That's just equal to 8. And 6 minus negative 2 is also equal to 8. So by using this double inverse property, we're able to simplify expressions that were initially kind of complicated. Okay, let's look at another example. You can do this even when you have variables. So 3x plus negative x. So some people are like, oh, well, that's negative 4x because I got a negative, I got a positive, they combine. Well, no, I don't want to bother with that, right? Let's do this the exact same way. So I think, okay, I keep the 3x. Okay, so I still have 3x. And then I say, what is the inverse operation of addition? Well, the inverse operation of addition is subtraction. And what is the numerical inverse, the additive inverse of negative x? Well, that's positive x. And so 3x plus negative x is the same thing as 3x minus x. Well, that's 3 of something minus 1 of something. That's just 2x. And it's that straightforward. Now, this is really what's going on when we've been distributing negatives. Let me show you what I mean by this, right? This is kind of an amazing thing, right? What if we have something like, hey, why aren't you clicking? What if we have something like 4 minus 2 plus x, right? And we've said, okay, well, this is subtraction. I can't really distribute subtraction, right? This is weird. Well, remember, this is actually 4 minus 1 times 2 plus x, which is really, right, if I use this double inverse thing again, it's 4, right? The inverse of subtraction is addition, and the inverse of positive 1 is negative 1. This is 4 plus negative 1 times 2 plus x. And this is what we're distributing. We are distributing the negative 1 to these two values here, okay? This is how we're able to distribute. You can't take a subtraction symbol and distribute that. That's not what's going on. We kind of gloss over that sometimes. We kind of ignore that, but this is really what's happening. And you can see how useful double inverses are to helping us simplify stuff. And that's why we end up with this expression, right? Being able to write it as 4 plus negative 2 plus negative x. And then we can double inverse that and keep going with stuff, whatever we need to, right? The idea is this is the underlying thing, this is the underlying mathematical principle that lets us do all these shortcuts that we like. And it ends up being really useful. So good luck practicing, good luck making sense of that. Ask us questions if you got them. Take care.